Hello everyone, let us introduce ourselves. We are S. Prashanti and SK Shahina, currently pursuing Electronics and Communication Engineering at ANU College of Engineering. We would like to present our 2-month internship on embedded system, and our project presentation is on microwave oven simulation. We would like to express my sincere gratitude to Ematex Technologies and its entire team for providing me with the opportunity to undergo an internship in the field of embedded systems. We are deeply appreciative of the trust and confidence that you have placed in our by offering this valuable experience. We extend my heartfelt thanks to every member of the team for their guidance, support, and encouragement throughout the internship period. Your expertise has been a significant. It has been stepping stone in our professional development, and we are thankful for the opportunity to learn about it. Once again, thank you overall Ematex Technologies and its entire team for this enriching internship experience. We are truly honored to have been a part of this esteemed organization. Topics that we learned during internship are: C is a general purpose language and middle level language which can be used to develop software with like operating system, databases, and compiler and portable applications. It develops C programming language. It has been various data types like int, float, character, etc. And also we have learned about arrays, pointers and functions, storage classes and preprocessors, introduction to embedded systems and microcontrollers, microprocessors versus microcontrollers, overview of MPLAB, IFDE, PIC-SIMLAB and XCB compiler, introduction to CLCD and interfacing CLCD, Disha workshop. So now these are the contents of our internship. They are: introduction to embedded system, microprocessors versus microcontrollers, microwave oven as an embedded system, requirements of the project, architecture of PIC-SIMLAB, internal architecture of PIC-16F87778, project demonstration and learning outcomes. Now, coming to the definition of embedded system. An embedded system is a computer system, and it is a combination of a computer processor, computer memory, and input-output peripheral devices that has a dedicated function within a larger mechanical or electronic system. And the other definition is, and the embedded system is an isolated system specially designed to perform a designated function with the help of its hardware and embedded system software. Now, the embedded system structure and diagram. In terms of hardware, a basic embedded system would consist of following elements, that are sensors, which convert physical sense data into an electrical signal, and analog to digital converters, change an analog electrical signal into a digital one. Processors process digital signals and store them in memory, and digital to analog converters change the digital data from the processor into analog data. And the last one is actuators. Compare actual output to memory stored output and choose the correct one. Then the categories of embedded system. Embedded systems are classified based on performance and functional requirements as well as the performance of microcontrollers. These classifications can be further divided into categories and subcategories. While classifying embedded systems based on performance and functional requirements, embedded systems are divided into 4 categories: real-time embedded system, standalone embedded system, network or networked embedded system, and the last one is mobile embedded systems. Coming to real-time embedded systems, real-time embedded systems are computing systems that interact with external world and have a specific timing constants. For example, it includes like anti-clock banking systems in cars, medical devices, and industrial automation systems. And real-time embedded systems are critical in applications where timely and accurate response are essential. Where coming to standalone embedded systems are independent computing device that perform specific functions without needing to connect to other systems. They operate in isolation and self-contained designated to particular purpose like micro ovens, digital cameras and washing machines. Coming to embedded systems of network or networked embedded systems refers to interconnect embedded device communicating with each other often in real time to achieve specific tasks. These networks can be wired or wireless and they are present in applications like smartphones for home automation, industrial automation, and IoT like Internet of Things setups. And finally, coming to mobile in embedded systems, mobile phones or smartphones contains various embedded systems that enable their functionality. This includes processors, sensors, and communication modules. Mobile phones can connect to different types of networks such as cellular networks like 4G, 5G, Wi-Fi networks and Bluetooth systems and everywhere from the dedicated standalone devices to interconnected networks, and these plays a crucial role in now modern technology. So let us come to the examples of the embedded systems. The examples of the embedded systems are smartphones, smartwatches, traffic lights, medical appliances, phones, refrigerators, Wi-Fi connections, robotics and micro oven, washing machines, meters and telephones and the automobiles. Now, so coming to the differences between the microprocessor and microcontrollers. Microprocessors and microcontrollers both are essential components of digital devices, but they serve different purpose and have a distinct characteristics. Coming to microprocessor, a microprocessor is a central unit. It is the brain of the computer system. It is designed to perform arithmetic and logic operations. Microprocessors are used in devices like desktops, computers, laptops, and servers. They require external components like memory, input output devices, and peripherals to function effectively. It has less internal register storage, so it has to rely on external storage. So, all memory operations are carried out using memory based external commands, which results in processing time. Coming to microcontroller, a microcontroller is a compact integrated circuit that contains a processor, core memory, and programmable input output peripherals. Microcontrollers are designed for specific tasks and applications such as embedded systems and electronic devices. They are commonly found in everyday like devices like micro ovens, washing machines, and automatic systems. Microcontrollers are often optimized to low power consumption and real-time processing make them suitable for control-oriented tasks. It has many resistors, so processing time is less, while microprocessors are more versatile and used in general computing applications. Microcontrollers are specialized chips to specific tasks offering to balance of processor, power memory and input output capabilities to compact form of this. So now coming to microwave oven as an embedded system. Introduction. Microwave oven is an electronic oven that heats and cooks food by exposing it to electromagnetic radiation in the microwave frequency. The microwave oven is a household appliance that has revolutionized modern home kitchen. Microwave ovens are so quick and efficient because they channel heat energy directly to the molecules inside food. Now there are various in microwave oven. The following four modes will be implemented, that are micro mode, grill mode, convection mode, start mode. Micro mode. In this mode, food is cooked in a traditional way. It uses a maximum power of 900 watts and the maximum time that we set for cooking is 60 minutes. Now coming to second one, grill mode. This mode is simply used for grilling. There is another grill heater placed in a specific location that can provide the grill effect. Now coming to third one, convection mode. In this mode, the heater is turned on and the fan is provided within the microwave chamber that circulates air throughout the chamber to give that baking effect to the item that is placed inside. Now, so for designing my project, the main component of designing microwave oven is PIC-SIMLab architecture. Coming to PIC-SIMLab architecture, there are many important components associated with it. And there is a microprocessor is PIC16F877A, and it is used in my project. I have to explain about a microprocessor and general purpose registers, analog to digital converter, and keypad matrix and assembly data types to store this data. So the overall PICSimLab is a real-time emulator of development boards that are integrated MPLAB X debugger. It supports several devices that can be connected to the boards for simulation. So to implement my project, I am going to use the simulator board, and coming to peripheral of this board, the peripheral of this boards follow the microcontroller PIC16F877A. It is called as a microcontroller, and it is the heart of the real-time AO chip and the RTC chip, and this RTC chip is also called as real-time clock chip. And we have LCDs that are also called as LCDs because they are displays of 1, 2, 3, 4, and they are also called as SFG displays. And we also have RBL, RB1 and RB2, and are also called as switches, and these are some of the digital keypads of it. Here they are called as 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is called as switches that are in row and column. So this is called as matrix keyboard. And there is a pan heater cooler buzzer LM35, and we are also having buzzer and cooler. So now coming to this green color screen, we have this called as LCD, liquid crystal display, and also there are lots of components. So we have seen that lots of components are connected to this board. So now I am pointing this are called as potential meters. So this is overall peripheral of this PIC simulator board. Coming to PIC167877A microcontroller. So this is the picture of microcontroller chip, and this is the photo of pin diagram, and it is the PIC16F877A microcontroller. It is a 40-pin microcontroller designed, and it is used at RISC architecture and manufactured by the Microchip, and it is commonly used in embedded system project. So it supports both hardware and software in like pin interrupts and timers in 16-bit peripheral. It also supports many protocols like serial box and having the parallel protocols. So this is the block diagram of the internal architecture of PIC16F877A of the PIC microcontroller. PIC microcontroller is built around Harvard architecture. There are two memories. One is for program and the other is for data, and separated this program memory. We can see the data memory separated by buses and are also used to program and data memories. And PIC microcontroller uses RAM and known as file register to store data during the execution and working. Registers to perform arithmetic and logical functions. We can say a multiplexer, and the user program is stored in the flash memory, and the status register to indicate the status of the microcontroller. And it also have 5 ports from port A to port A to port 7, port B to port C, and port D. So coming to brief explanation of CLCD. LCD, liquid crystal display, is a type of flat panel display which uses liquid crystals in its primary form of operation. LEDs have a large and varying use cases for consumers and business, as they can be commonly found in smartphones, televisions, computer monitors, and instrument panels. The main advantage of using CLCD instead of 7-segment display and other multi-segment LEDs is that there is no limitation in displaying special and custom characters, animations, and so on. Most importantly, the module can be interfaced much easily, unlike other modules with no complexity in both hardware and software. In PICSimLab, there are two types of display, 16:2 display and 16:4 display. ASIC characters are some characters that are displayed. There are also two types of communication mode that are used are 4-bit mode and 8-bit mode. A CLCD that consists of two registers. One is command register and the other one is data register. Now coming to next point, tactile switch. A tactile switch is one type of widely used switch that completes an electrical circuit typically when pressure is applied to the device by the user, which then gives the user a perceptible click or haptic bump in response, indicating current flow. Current flow is turned off when the switch is released. There are optional features such as size, board mounting, and ceiling structure for us to select for their applications. My project use this switch to select the mode of operation as well as to set the temperature and time. Now, bouncing effect. Bouncing effect means there is a metal plate and terminal. Spurious pulse detection while pressing releasing the tactile switch is called as bouncing effect. Coming to next one, matrix keypad. Matrix keyboard. A matrix keyboard is a small compact input device that accepts user inputs and processed by microcontrollers. A matrix keypad is the kind of keypad you see in microwave ovens, gas pumps and calculators. It consists of number of tactile switches that are arranged in a row and column format. The advantage of matrix keyboard is that the use of it will allow the programmer to reduce the number of pins to be used. And now the interrupts and interrupt service routine. What is interrupt? An interrupt is a signal to the CPU to immediately begin executing different code that is written to respond to the cause of the interrupt. An interrupt is a communication process that is set up in a microprocessor or a microcontroller in which an internal and external device requests the microprocessor and microcontroller to stop the processing, and these microprocessors and microcontrollers the request and attend the request. Interrupt service routine. An interrupt service routine is a software routine that hardware invokes in response to an interrupt. Interrupt service routine examines an interrupt and determines how to handle it, executes the handling, and returns a logic interrupt value. A basic example of an interrupt service routine can be a routine that handles keyboard events such as pressing or releasing any key. And the next one is timers. Timer is a clock that controls the sequence of an event while counting in fixed intervals of time. A timer is used for producing precise time delay. The timer is an important application in embedded systems. It maintains the timing of an operation in sync with a system clock or an external clock. The PIC16F877A PIC MCU has 3 timer modules. They are named as Timer 0, Timer 1 and Timer 2. The Timer 0 and Timer 2 are 8-bit timers and the Timer 1 is 16-bit timer. These modules helps to perform various timer, counter or PWM generation. Our project demonstration is microwave oven simulation using MPLAB X IDE and PIC Simulab software. So this is the PIC simulator board. So that first, in order to start with the demonstration, we need to configuration of few things. So this is the using fix enhance and microcontroller PIC F877A. So we can consider a microgill convection start for displayed on this. So before this we displayed on this green screen. So before that I said earlier that micro oven is an, so we can see that on green screen. So before that I said earlier that microwave oven is an electric oven and it heats and cooks food by exposing it into the electromagnetic radiation into the microwave frequency wave range. In this busy life, microwave oven very helpful for some cooking purposes. So after that configurations, we now start the demonstration. So I have told about the configuration that LCD, liquid crystal device, here is of two types. I told earlier, and the LCD is of two types, and one is 16x2 and the other one is 16x4. In my project I used 16x4. Now, so that there are 4 modes in my project. That is, first one is micro mode, grill mode, convention mode, start mode. In order to implement the micro mode, we need to press 1, and in order to implement grill mode, we need to press 2. For convention mode, we press 3. For For start we press 4. So let's start with micro mode, and I will be pressing the mode 1. So the maximum power set is 900 watts and the time displayed is in minutes and seconds, and I am setting time for 2 minutes 50. In order to clean the value or erase the value, I have to press the start key. So it clears displayed value and enters 0. Now I will be giving new value as 40 seconds. In order to enter of this, I have to press hash and enter key. So now we can see the timer has started and pan has to rotate it. So in order to reduce this pan, we need to press 4 and press 5, and to stop we need to press 6. So this we have to press 6. I will be pausing my device. Now as we can see that I am pausing my time, and the time is 22 seconds and the fan stops rotating as well as. So to resume the time we need to press 4. So we can see resume 4 and fan has started rotating and the buzzer is shot on beyond the left side. So here is the buzzer sound. The buzzer sound is here and the cooking is completed and is displayed in the screen. So now we have done with the micro moving on the grill mode. We need to press 2. So just like your microphone, we need to give some time here, and we will be giving 40 seconds and enter hash key to enter, and same for the 4 to resume and 5 to pause and 6 to stop. If I press 4 without pausing the timer will be implemented by 30 seconds. So I press 4, the time off has been implemented to 30 seconds. I press 4 again, implemented 30 seconds. In order to stop this, I pressing 6. In order to stop timer, we have to press 6. So the timer has to stop. PicSimLab has stopped. So we completed micro mode and grill mode. Moving to convention mode, we need to press 3. So the time temperature is entered in Celsius and it is in the Celsius degrees form. So the temperature is set to maximum of 250 degrees Celsius. So any value about 250 degrees is considered as an invalid try to be given. Some value about 250. I have given 300 degrees centigrade. And we can see that enter value is of temperature is in the message displayed on the screen, and the buzzer now will give valid temperature is of 24 and 24 seconds, and press enter, and we can see the preheating phase, and the time is already set to 3 minutes. So it will start preheating over 3 minutes and it prevents the 0 for damaging, and just wait for 160. Now I can and set. So now I can and set, and just like micro oven and micro oven. So let us wait for some more time. Let us wait for 90 seconds. So now I have set time just like a 90 seconds. And the time count down to 0, and the cooking time is up. So now has set time just like a micro mode and grill mode. I will be setting for 15 seconds and hash enter the same 5 for PA and 64 stop, and the time countdown starts, and the countdown starts and the countdown to 0, and cooking time is of message is displayed with the browser. And the last mode of this implementation is the start mode. To implement this mode, I have to press 4. This is initially automatically set to 30 seconds, and I mean I have not to enter seconds, and 5 per pass and 6 plus stop. Now it is cooking, and to stop this we have to press 6. The countdown shows us to occurring. Now the cooking time is displayed, so I have to implement all 4 modes in my project. So what is the differences between the micro mode and the grill mode? The micro mode is set at the low temperature, and the grill mode is set at the high temperature. So for example, in the micro mode we can cook food like popcorn and some other low temperature foodies, and for the grill mode especially for like us vegetables, and for special things like grilling species of like food like vegetables, and add some spices for the convention mode. We can set the preheat for the particular temperature, and this can be used to bake the cakes, cookies, and etc. And for the start mode for just heating purpose like water and burn, etc. So this is the demonstration of my project. And the micro learning outcomes of my project are: gained in-depth knowledge about internal working of embedded systems, hands-on programming and domain skills, introduced to different software along with interfacing, real-time experience, exhibited better solving skills by analyzing underlying issue to challenges, good exposure in standard industry practices of software and development. Thank you. Finally, we would like to thank the Ematex Technologies and its entire team for giving me this opportunity to gain my technical logic. I would like to thank my mentors and who has explained me this project and supporting me and guiding me for this internship. Thank you.